electrical resistance
सर ब्लर आ
blur આવે
ना क्लियर आ देख ना ब्लर आ क्लियर आ
એટલે ફોકસ લોક કેવું કે હોય છે
હવે ક્લિયર કે
થઈ ગયું હવે થઈ ગયું ને ઓન કર્યું so exercise question 11.3 the electrical resistance in ohms of a certain thermometer varies with temperature according to the approximate law. Approximately, this is what we get: 1 plus alpha into T minus E0. Okay, right? So what does this mean here? It means E0 is some reference temperature. Okay, and at that temperature the resistance is R0. So resistance at reference temperature. Okay, alpha is called coefficient of variation of resistance. Okay, coefficient of variation of resistance means coefficient of change in resistance, because as temperature will change the resistance will also change. That's what this formula is telling you. To different value of T, you get a different value of T. Okay. So the resistance is 101.6 ohm. Resistance is how much? 101.6. And triple point of water, which is temperature 273.16. So when T is that, R is this. You could call it T1 and understood. Yeah. Then 165.5 ohm at normal melting point of lead, which is 600.5. So another temperature is given, and at that temperature, how much is the resistance? That is also given. Okay, we just have to use this formula basically. આની પાછળ કઈ logic નથી except one simple sentence that as temperature changes, resistance of a substance also changes. Right? Why it changes, how it changes, all that question. Right? Here we are given this formula, we just have to apply it. Okay. What is the temperature when the resistance E is how much? 123.4 ohm. What is the here? Question clear? At this temperature, this is the resistance. At this temperature, this is the resistance. And then, if the resistance is 126.4, then how much will be the temperature? Okay. So we are going to use all this data. Alpha is not given first. Look at this. R0 from resistance at reference temperature, T0 reference temperature. एक ही value नहीं दिया था. But we will use all this to find it. Okay. I am going to simplify this a little bit more. Okay. formula देखा है ये complicated नहीं, but let's on the way. Have a look. I equal to R0. I am opening the bracket. I am not doing anything. Clear or not clear? R equal to R0 plus alpha R0 into T minus T2. Now I am going to put R minus R0 on left side, so that is R minus R0 equal to alpha R0, and instead of T minus T0 later we will put delta T. Delta T for what? Temperature difference or change in temperature from the reference temperature. And similarly here change in resistance from the reference temperature. Understood? Left side, right side, both. Okay, R minus R0 delta, T minus T0 delta T. So this is another way to write the same thing. अभी एक अच्छे base steps करा हुआ है. Okay, okay or not okay? Now why do we use it that way? Because it's still easier. Let's start. So here we are given two temperatures. Generally it's that the first one we consider it as reference. Okay, when there are two such things given, we consider the first one as okay. So did you understand what I have done? Using number 1 and number 2. Okay or not okay? Sure? Clear? Now similarly using number 1 and number 3, I can write this. Okay. Is this clear? One and 2, if you use 1 and 2, we get R2 minus R1 equal to alpha R1 what P2 minus P2. Okay? Just like that, if you use 1 and 3, okay, first and third temperature. So what do you get? R3 minus R1 equal to alpha R1 is replaced. You might have a question, can't we do it like this? Can't we do it like this? The answer is no. Because in this formula you need to have a fixed reference temperature. એટલે એવું ન ચાલે કે એકવાર તમે રેફરન્સ ટેમ્પરેચર T1 અને R1 resistance reference and the second time you take it R2 T2. No, not well. So you have to take it same. Got it? Okay, so now we have got these two. We don't know the value of alpha. एक और unknown है ना, and we have to find P3. Let's divide. If we simply divide using actual sum or plus है जो use this formula, write this and divide. Okay, let's divide. So R2 minus R1 upon R3 minus R1 equals, what should I write on the right hand side? T2 minus T1 upon T3 minus T2. So what to do now? Solve values. Do the calculation. Hurry up. Do it fast, within a minute or so. Done. Done. Okay, so here we are. Done. You get it? Okay. We have R2 minus R1. So you just subtract these two. 165.5 minus 101.6, 63.9 divided by R3 is this and R3 minus R1 is what? 21.8. 21.8. Okay. Equal to T2 minus T1, the difference of temperature over there. 300.5 minus 273.16. 327.3, and here we have T3 minus 273.16. So now divide this here, 63.9 divided by 21.8, so you get 2.93. Okay, and this is close there. So ultimately T3 minus 273.16 equal to 111.67. 111.67. So T3 equal to, add to that 73.16. So you get 384.83. Okay, take the up at the back. Point. Right? So that's it. Now we can run on a okay. Now let's go to the next thing, which is about thermal expansion. Okay, thermal So what is thermal expansion, and typically of solids right now? Then we'll talk about gases or fluids. Thermal expansion of solids. So you will be knowing that if you heat something, it will grow in size. Okay. Now, whenever you heat an object, its length will increase, its area will also increase, and volume will also. Now that happens because every dimension that is every side in every direction is going to become larger. Understood? So right now we will talk about length. So like let's say there is a long wire. Okay, or such object whose length is much more compared to its width, or ruler, for example. A ruler is fairly long, but its width and thickness is not that big. Agree? So for such objects, we are going to first of all talk about what happens to length. Okay, what happens to? Now, it is reasonable to assume, listen to this step, it is reasonable to assume that whenever you heat an object, right, let's say at start, okay, initially, at temperature T0, let's say start at the temperature T0, let's say the length PL0, at some reference temperature, at some reference temperature, T0, the reference length is L0. Now suppose you heat it, that is, as you heat it, the temperature will increase. Let's say it increases by delta. Then do you realize that because the more you heat, the more the temperature increases, the more the length will increase. So it is reasonable to assume that the increase in length is proportional to increase in temperature. You understand that? The increase in length is proportional to the increase in temperature. That is what we have often. It's not necessary that all objects have to follow this only, but it is that most common or routine objects that we see around us, for example, rods of steel. You understand what I'm saying? Okay, or such objects that we commonly use in such structures, let's say building, this bench, these kind of objects, they do follow this fairly closely. That is, the change in length is directly proportional to the change in temperature. Okay, right? Also, one more thing to understand is that change in length should actually be proportional to the reference length or the original. You might be wondering why it should be like that. Okay, this might seem reasonable, but this one is a bit strange. What this means is, whatever is its length, if it's more, then the increase in length will be even more bigger, right? So that is, increase in length depends on the length. What happens? Suppose that there is a small length, okay, of some material. Okay, picture just for simplifying. Okay, there are a few atoms on it. Now what happens is, when you heat them, they will go away from each other, right? Because of heating, they get energy, and when they get energy, right, they try to go away from each other. That is, they try to weaken or loosen the attraction between each other. So instead of being like this, it would turn out to be something like this. First still here, the second one slightly far away, slightly far away, like that. Let's say the length increases and it becomes something of this. I don't know whether I have drawn for you. This is like this. So, do you realize that if there are only 6 such molecules or atoms, assuming very simple, you get it till here. What if instead of 6, there were 60? What if instead of 6, there were 60? Here the change in length is only this much. But do you realize that if there were 60, then there will be more increase in length? Try to imagine it, or use the analogy. Here is the analogy. And then there are 3 people, okay, standing like this, okay, with their hands connected to each other, like making a chain. Okay. Now if for some reason their arm length would increase, let's say by a small amount, small fixed amount, then those 3 people now would make a slightly longer chain, yes or no? Let's say everybody's arm increased by 1 centimeter, they will make a slightly longer. But now imagine that if the original chain in this new case is not made by 3 people, but say by 30 people, what do you think is going to happen in this case when everybody's arm length increases by 1 centimeter? Suppose bada's arm 1 centimeter each increase size, only 2 centimeter and 2 centimeter. This increase will be only 4 centimeter. But here, there are such more number of connections, isn't it? So if all those will increase by 2 centimeter each, the change in length will be bigger. Make sense? So what I am suggesting is that the longer the length is, that is L0, if it's more, then for the same increase in temperature, the change in length will also be got it, right? That is delta L, then change in length or increase in length will be proportional to delta T, and similarly change in length will also be proportional to delta. So now when we combine these proportionalities, we get delta L will be proportional to L0 and delta. Clear or not clear? Okay, and we have a habit, whenever we see proportionality, we try to remove it. So let's remove it. So we should write a constant. That one will be nothing but that's everything. You realize we have explained or we have gone through how we should get something like that. Okay? So what is alpha again? Alpha is a constant. Okay, which You could say coefficient, constant, it's a coefficient of temperature variation or change with temperature. Okay, coefficient of whatever. Here, if you are talking about length, then it is coefficient of temperature variation of length. So, what is it? Temperature variation of length. That means how length changes with temperature. That is what alpha indicates. બોલો આની પહેલા સમ કર્યામાં શું હતું રેઝિસ્ટન્સ. That was the coefficient of change of resistance with temperature. Here it will be coefficient of change of length with. Understood? For clarity, you may write alpha L. See, what is the meaning of alpha L? Coefficient for change of length. Got it? Clear? Everyone understood this whole thing? So this is about length, right? Now I'll ask you one simple question. Okay, which is essential to understand. Suppose there is a rod lying free on a table or on floor in a room, and you start heating the rod. Let's say by putting some heating mechanism in the room. So if its length will increase, it will समझ पड़ गई ना why the length will increase, because the molecules will try to go away from each other because of higher energy. So in which direction will the length increase? खाली आप right side and लांबूगा है कि खाली left side and लांबूगा? It will expand on both sides. Is that clear? If it is free that is nobody is holding it. But suppose you have fixed it. Generally, how is it normal? Whenever we try to do some experiment or we are using it, let's say we have clamped it here. Clamped it means fixed it. Now if you will heat it, then in which direction will it increase in length? Then it will increase towards the free end. Basically, wherever is the free end, it will try to increase the length towards the free end. Concept clear or not clear? अब जो क्या बनेगा? Because there would be opposite force. Understood? Because there is a clamp. And if molecule आप जवानी try करें तो नहीं जा सकते because there is something else. Got it? So all the increase will be on this. Absolutely clear. Okay. The emergency one. You can imagine what will happen, right? It's like the rod is trying to grow, but the clamp from both sides are going to apply force on it. Force આ બાજુ લાગશે અને ઓલી બાજુ force લાગશે. ऊपर नीचे तो expand થાય, but that would be negligible because generally rod has negligible width compared to length. समझ होता है? Compress. You know what's happening here? Chapter 9 याद करो. Here the increase in temperature will try to increase the length, but the forces acting from two sides will try to decrease the length. याद आया है? Compression, tension, tensile stress, compressive stress. याद आया कि नहीं? Chapter 9 properties of solid में होता है ना. So basically here both the effects. In such a case, both the effects are going to cancel each other. So two effects. Which two effects? Temperature will try to increase the length, and force will try to decrease the length. The total effect, net effect will cancel, and you will get no change in length. Got it? Concept clear? अब एक चीज में क्या होता है? You can say that the increase in length अलग है. Okay, आप अलग से आप एक करिए. And question है पूछा है. Put a little title here. Thermal stress in a rod. Thermal stress in a rod. So we are talking about thermal expansion of solids, and we discussed a little bit about length. Now we are talking about a special case of that, where you have a rod clamped between two walls or two clamps so that it cannot expand. And now if you increase temperature, you can say that due to increase in temperature, the increase in length should be okay, it's not there but it should be for delta L equal to L0 alpha delta T, right? But the compressing force F acting from clamp or wall will decrease, or will try to decrease the length by same amount delta L. So what does this mean? Due to increase in temperature, the rod wants to grow by how much? By delta. But the forces acting on two sides will not let it grow, and they will try to decrease that length. So ultimately the length will become same. Okay, so same amount increase and same amount of decrease. So they cancel each other. So यहाँ पे एक relation जो तो ऐसे कैसे है? Here, delta L equal to delta L. That's what we are going to do. Okay, one side is increase, the other side is decrease. So when we write delta L for temperature change, I should write L0 alpha delta T. Clear or not clear? Sure, got it?
alpha चाहिए proportionality sign.
Alpha तो बोलूँ जो, alpha बोलूँ जो, बराबर है? So L0 alpha delta T equal to, what's delta L due to compression? Recall chapter 9 formula, properties of solids. Delta L is to change in length. पूरी पूरी formula याद करो. M formula की formula याद है, y equal to F L by E L, right? And यहाँ L भी देखें तो से L0 original length FL0 by A delta L. So if you compare it this way, then delta L will be FL0 upon A what? Y for what? M. Did you understand that step? Left side માં increase મૂક્યું for temperature and right side માં decrease મૂક્યું for force. Okay, using this. So this way we can find out how much force F is acting here and here. One very nice. This way you can find out how much force F is acting. Or you can find out thermal stress. What's the meaning of thermal stress in terms? Thermal means what? Related to temperature. Stress, you know, F upon A. Got it? So thermal stress F upon A will be equal to, what should I write? What should I write this? Pi alpha delta T. Okay? Do you need to memorize this formula? No, I say there is no need. Yes, but you should learn the concept. જો આ સમજાઈ ગયું હોય તો આ મેમોરાઇઝ કરવાની કોઈ જરૂર નથી. મને પોતાને ખબર જ નહોતી કે આવી કોઈ ફોર્મ્યુલા આવે. there is no need. Why should I remember? આટલા ત્રણ કોમન સેન્સ જેવા સ્ટેપ્સ આવડે ને, ડેલ્ટા એલ ઇન્ક્રીઝ, ડેલ્ટા એલ ડિક્રીઝ, બે ઇક્વલ મૂકી દો ફોર્મ્યુલા બધી આપણે તો આવડે જ. Okay, what could a typical question look like? Let's say that okay, there is a rod of length 1 meter which is fixed between two walls at temperature, let's say 25 degrees. Now the room is heated and the temperature of the rod becomes 50 degrees. Then they might say find the force applied by the wall on the rod. Find the force applied by wall on the rod, and if the area is given, you can multiply it on that side and find. Stress पूछे, find the stress developed in the rod. Understood how questions could be there, right? Okay, so that's about increase in length. Clear? Okay. So first part complete. Now when we raise everything, let's go to exercise. I just recall This calls to it alpha. Alpha एक term है, alpha is called coefficient of linear expansion. Coefficient of linear expansion. Again, this is what does this mean? This means relation of length. You see that coefficient linear. Linear means referring to line or length. Name is clear. Or you could also say coefficient of variation of length with temperature. બધા વર્ડ નો મીનિંગ છે તો what is how can you તો confuse ન થઈ જતા what does coefficient of linear. Okay, so this is another name for us. ચલો હવે exercise કરવાની example છે હોઈ શકે. Fine, let's look at the example first. Example, okay. 12 to 11.1. Example 11.2. It is on page 283 in this example 11.2. Okay. A black space fixes iron ring on the rim of a wooden wheel of a horse cart. So what's this saying? It's saying that there is a wooden wheel. Okay. And on that wooden wheel, a blacksmith wants to fix what? An iron ring. Can you imagine what I'm saying? Okay. The diameter of the rim and the iron ring are this and this respect. So a wooden wheel, okay, and black is the iron ring. So I'm saying diameter of wooden wheel. You see the diameter of rim and the circumference diameter is 5.243 for the wheel or wooden wheel. Is that okay or not okay? 5 meters. Horse cart to be 5 meters. Diameter 5 meter. A horse cart check. And diameter of the iron ring. Okay. No confusion. Wooden wheel and iron ring equal. Okay, that dr equal to 5.23. Okay, so सरस हुआ. This is more than this. So giant thing. You understand what I'm saying? You want this ring to go over the wooden wheel, but ring no diameter तो अलग करता. ओछું છે ને? तो क्या करता है? It side. No that. So what do? We act smart. We heat this ring. So if we heat it, what will happen? The ring will expand. Okay. Now, actually, this is circumference or perimeter. Yes or no? Perimeter means length. It's a kind of length. Correct? Everyone gets that? Perimeter or circumference is a kind of length. So when we will heat it, for the ring, I should be able to use any of these formulas. Either this or this. Clear or not clear? આ તો તમને ખબર છે કે કેવી જાય delta L equal to L0 alpha delta T. એવી રીતે આમાં D0 alpha delta. D for what? Diameter. D for diameter. Because diameter is a kind of length. You can also do it for circumference. For example, you can also write delta C equal to alpha C0 delta T. Because circumference is also a kind of length. Make sense? Linear એટલે length related કંઈ પણ હોય બધામાં ચાલે. Perimeter માં ચાલે. Area માં નહીં. Area is not a kind of length. Got it? સમજાય છે ને? તો it would use like this. અચ્છા આ શું છે? We need to explain. જેમ આમાંથી આવું ડિરાઈવ કર્યું હતું yes or no get an example એવું તમે ઊંધું કરી શકો ને instead of delta t what to write so like this step લખી દો instead of delta t what to write d minus d0 equal to alpha d0 instead of delta t what to write t minus d0 થોડું ઘણું મેથ correct basically putting d0 on opposite side and then taking common. Okay or not okay? So there are two ways. So I would expect that you remember at least one of these two formula. એટલે આ ઓલી L વાળી છે. Delta L equal to L0 alpha delta t or L equal to L0 1 plus alpha t minus t0. Clear? પડે છે ને કે કન્ફ્યુઝન થાય છે? Length માં આપણે એક લખી એરિયા બીજી લખી શકો છો એની બીજી. Never mind. So coming back to solving this question. The idea is we heat it. So when we heat it will grow in size and benefit it. Correct? So from this diameter we have to increase and make it 5.243. Correct? And heat karo વધી જવું જોઈએ આટલું થઈ જવું. So let's read the question. To what? Okay, this was at what temperature? 27 degrees Celsius. So this is like our reference temperature. This is the reference. What's that? So from this we should increase it. So to what temperature should the ring be heated so as to fit the rim of P? એટલું તો સમજાય કે આને ઇન્ક્રીઝ કરીને આટલું કરી નાખો ને તો થાય એની પહેલા ન થાય. So let's start. What should I write? I'm going to use this or this. Either way, I'm going to use this delta t. So what is delta t? 5.243 minus 5.231. Clear? Equal to alpha. Is alpha given in the question? Okay, not given. We'll have to see it from the table, I believe. Iron no I2 alpha. On page number 281. Page number 281. Do you see your table? Imagine iron. So alpha is 1.2 into 10 raised to minus 5. Right? 1.2 into 10 raised to minus 5. Over 10 raised to minus 5 like this. Okay. And now into delta t. Delta t means final temperature minus reference temperature. Got it? Into delta t, final temperature t. We don't know. To what temperature should we heat? We don't know. But we know that the reference temperature is 27. The initial temperature is 27. Clear? This is in which unit? Degree Celsius. So we are doing T minus this. So this is also in degree Celsius. And if you Kelvin ma karo, to પછી પાછું Kelvin ma. So it really is your choice. કઈ ફરક પડશે નહીં. Got it? Whether you do it in Kelvin or Celsius. Right? Still, if you want to, convert, you can do it. Okay, it's not necessary. I'm not doing. So here, subtract 0.0. Why is that? 0, 1. Oh, sorry. 0, 1, 2. Equal to 1.2 10 raised to minus 5 into t minus 27. So here this is nothing but 1.2 into 10 raised to minus 2. Clear? So a lot of things are cancelled. So what will we get? Therefore 1000 equal to t minus 27. So t equal to 1027 degree. Understood? What was clear? My other answer I would not know.
D0 nothing.
So D0.
D0.
D0. Okay. If I got to take D0, I'm so sorry here. So we have to take D0. All of this is wrong. So here if we write D0 that is 5.231. So into 5.231 and similarly into 5.231. So here we divide by 5.231. Okay, so this is wrong. 1000 divided by 5.231. We have to do that. So what do we get? What is the 1000 upon 5.231. 191.16. Okay, and ultimately T equal to 191.16 plus 27. 218.16 degree. Okay, so that is what, right? Fine. Continue with it later.